Hello dear students, welcome to my channel Kaveri Science Tutorials. Today we are going to start the first chapter of Science 1, that is gravitation. So we are going to see the meaning of gravitation. We have seen in the previous classes that the force of attraction due to earth, due to which the things fall in downward direction. It is the force of attraction due to earth which is directed towards the center of the earth. The diagram is shown in the textbook. There apple tree is there and the apple is falling on the surface of the earth. Apple tree is there and the apple is falling in a downward direction. So gravitational force is necessary to fall any object to fall in the downward direction. And the great scientist Sir Isaac Newton has got success in successfully done the study of gravitation. And he studied, we know this famous story related to him, that he was sitting under an apple tree and he saw that the apple fall occurs in the downward direction. So he started to think over that. So why the apple fall in downward direction only, and it does not fly in any direction, or it does not go in fall in any other direction. So he started to think over that. After his thought, he concluded that the earth's gravitational force attracts the object towards the center of the earth, and therefore the things, whatever apple or whatever falling things, they fall in the downward direction. So Newton has done tremendous work in case of science uh, related with heat, sound, and mathematics, and other areas are also there. But he was the successful scientist to study gravitation. Many other scientists also have studied this gravitation, and but he was the successful scientist. Newton was the successful scientist. So so what is mean by gravitation? We will repeat the definition of gravitation. The force of attraction due to earth which is directed towards the center of the earth is called as gravitation. The force of attraction due to earth which is directed towards the center of the earth is called as gravitation. So we know that any kind of motion of an object, there is a requirement of a force. If we are going to apply force on a box, then and we are pushing the box, then the motion of that box takes place in linear way. So similar to linear motion, there is another type of motion, that is circular motion. So in circular motion, the objects revolve in along a circular path. The objects revolve along a circular path, then it is called as a circular motion. Then how the moon is revolving surrounding the earth, moon is revolving a circular path because of the force which is called as centripetal force, and it is directed towards the center of the earth. One activity is given in the textbook, that is, you have to hold a string in your hand and tie a stone to the another end of the string, and you have to revolve the string. While revolving the string, at some point the stone will fall from the stone will fall from the string. The stone will release from the string and it will release in a tangential direction. So tangent is a line which is perpendicular to the radius of the circle. So we are revolving the stone along a circular path, and if the stone is released from that circular path, it is released in a tangential direction to the radius of the circle, means it is at the right angle, or it makes 90-degree angle with the radius of the circle. Any example you can take? if a revolving disc is there and you are going to put a coin and the speed of the disc increases, the coin falls in a tangential direction to the circle. So this is the circular motion. And during circular motion, one type of force acts on that object. That force is called as centripetal force. That force is called as centripetal force. Centripetal means seeking towards center. Centripetal force. So the definition of centripetal force is the if an object is moving in a circular path, or an object is moving along a circular path, then the force acting on that object is directed towards the center of the circle, and that force is called as centripetal force. I will repeat once again. If an object is moving along a circular path, then the force acting on that object is directed towards the center of the circle, and that force is called as centripetal force. Centripetal force. So this is from your syllabus. One more thing, just for your knowledge, another type of force is there which is directed away from the center of the circle, and it is called as centrifugal force. When we we separate butter from buttermilk, and that's lightweight butter particles, they are thrown away from the center of the circle and they are collected at the surface of that buttermilk. They are it occurs due to the centrifugal force, just for your knowledge, and it is the opposite of centripetal. So just remember here in this chapter, so that the centripetal force is the directed towards the center of the force, and it acts on the object which is moving in a circular path. So this is about the activity we have seen and what is meaning by circular. So all the planets and the moon, or moon is revolving around the earth, all the planets are revolving around the sun in the galaxy. So they are moving with the force, and that is called as centripetal force. Due to the centripetal force, they are moving in a circular motion around that planet. So that the next part of this chapter is, before going to what the studies made by Newton, what is the universal law of Newton, it is given the three laws of Kepler are given in the textbook, because these laws have helped Newton to made his conclusion about the gravitational law, universal law of gravitation. How we are going to say? In this way, all the three laws we can't say, but the third law, Kepler's third law, has helped Newton to conclude his gravitational law. Therefore, the Kepler scientist and his laws are introduced in this chapter at first, before Newton's universal law of gravitation. So Kepler is a scientist who studied the planetary motion. Planets move around the sun, and their motion is studied by Kepler. So the Kepler stated that first law of Kepler is, an orbit of a planet is an ellipse with the sun at one of the foci. Okay. So this is an elliptical path of a planet, and it revolves, and this line is the orbit of the planet. Line in an elliptical shape is the orbit of the planet. So Kepler stated that an orbit of a planet is an ellipse with the sun at one of the foci. So it is an elliptical orbit, sun is at the one of the foci. Now what is ellipse? Simply it is given in your textbooks for your understanding. if this is a cone shape, okay, cone shape, and we are going to cut this cone shape from inclined manner, from an inclination we are going to cut this cone shape. Then the shape got by us is called as elliptical shape. Okay, so this ellipse is having like similar to the mirrors are having concave mirrors, convex mirrors, they are having the foci or focus is there for one mirror, but it is having two foci. Ellipse shape is having two foci, and in this elliptical orbit, out of these two foci, sun is present at the one of the foci. Focus is the, we have seen in case of mirror, one like this, for this is the midpoint of the circle for when the mirror is formed, and this is the radius of that mirror, we can say, and this middle point of between the center and this surface of the center of the circle of that mirror and the surface, the between this distance, the midpoint is called as focus. So one focus is for there for one concave mirror, we can say. In the same way, there are two foci in case of ellipse. So I will repeat the first law again. So the first law, Kepler's first law, states that an orbit of a planet is an ellipse with the sun at one of the foci. So next law is Kepler's second law states that the line joining the planet and the sun sweeps equal area in equal interval of time. Suppose this area is covered in t time interval, this also requires t, capital T time interval, and this. So same time interval, in same time interval, the area covered by that line joining the planet and the sun is equal. So we can say that here is point S, A, B and S, C, D. So the area SAB equal to the area of the SCD. In this way, the line joining the planet and the sun sweeps equal area in equal interval of time. That is the second law of Kepler. So I will repeat once again. The line joining the planet and the sun sweeps or covers equal area in equal interval of time. So time interval is equal, that is capital T. So it covers equal area in equal interval of time. Again, Kepler's third law states that the square of the period of revolution of a planet is directly proportional to the cube of mean distance between the planet and the sun. So period of revolution is the time required to cover one complete revolution. Okay, so the square of period of revolution is directly proportional, this is the proportionality sign, is directly proportional to the cube of mean distance from the sun, and it is studied or explained by Kepler. So for removing proportionality sign, we can write it as a t square equal to constant into r cube. K is a constant, therefore t square by r cube equal to k. K is a constant. So t square by r cube equal to k is the Kepler's third law. I will repeat the third law of Kepler. The line, the square of period of revolution of a planet around the sun is directly proportional to the cube of mean distance from the sun. So mean distance means we can take this distance, this one, and this one. So three distances we are going to take, add this distance and divide by 3. So this is the mean distance, because it is not exactly circular path, we have to take the mean distance because of the elliptical path. Therefore mean distance is shown by small r, and square of period of revolution of a planet around the sun is directly proportional to the cube of mean distance from the sun, and it can be stated that p square by r cube is equal to k. It means constant. So I hope you have understood. So I am going to stop here today. If you have any doubts, you can ask in the comment box. Hope you are liking my lecture. Some tricks are there. Some you will get some extra knowledge, basic concepts, and all you will be clear in our videos. Okay. So thank you very much and bye.